Welcome. I'm Bob Ward from Microsoft. Welcome to one of these great sessions in this around-the-clock tour for ADF and Azure SQL. So excited you're here today. Thank you for taking this time to be with us to learn more about ADF and Azure SQL, an event put on by the engineering team. Who else better to put on an event to talk about these topics than the engineering team themselves? So I spent a lot of time with SQL Server the last 27 years at Microsoft, but over the last year, I spent a lot of time on Azure SQL, talking to customers, users, doing a lot of presentations, boot camps, you name it, about how to kind of translate your skills from SQL Server to Azure SQL. And one of the topics I think it's important to understand to be successful in the cloud is something called a service level objective. So in the next 20 minutes, let's talk about it. We'll end the very end of the session with a demonstration to kind of show something. And then certainly we want your questions, so please post these and we'll either address them here during the session, or I know we have a Teams channel through the US sessions to also address questions afterwards. So let's get started and talk about what is a SLO, is what we call. You know, to give you some context, it's important to kind of know about decisions you make today. When you're deploying something like a SQL Server or database, these are the kind of things you decide whether you're using a virtual machine or using a bare metal type computer. You have different hardware resources, you have different editions of SQL features you're looking at, configuration options, high availability requirements. You put all these decisions together for a couple of reasons. And they are, you need predictable and scalable performance from your application, from your SQL Server. You have feature requirements for your application itself you need to meet. You have specific storage requirements for size and performance. And you certainly have, in most production environments with SQL Server, availability requirements. Things like RTO and RPO, or the ability to have certain disaster recovery requirements per your business or your application. So that's great. When you move to platforms as a service, though, when you talk about Azure SQL Database and Managed Instance, you don't have direct access to all this infrastructure. We are providing all this infrastructure. So you have to make certain decisions to decide, how do I translate these things I do today in my data center to the cloud, especially in a platform as a service environment? So we have this concept called a service level objective. Let's talk about what it is, how do you use this, and why is it even important to you? So number one, what a service level objective is, it's a compute choice you're going to make for goals for predictable performance for platform as a service. We also call this a service objective. Now, it's not a service level agreement. That is something that's like a contract with Microsoft or Azure for availability purposes, where if we don't meet certain agreements that you've set up based on your configuration choices, we have actually Azure credits. Now, your service level objective choice, though, can actually impact what that SLA will look like. And besides the fact that it's going to be a compute choice for predictable performance, it affects a bunch of other stuff. You're going to make certain decisions that are going to affect price you pay, certain capabilities you get, and other resource limits. So let's talk about how do you do this. Number one, you're going to choose a product. You're going to decide, I'm going to go Azure SQL Database, or I'm going to pick Azure SQL Managed Instance, and we'll show that comparison in a second. Once you make that choice, though, you get into these other choices that are going to end up determining what service level objective you get. That could be a pricing model, like what we call a D2, a vCore model in an Azure database, something called a service tier, a compute tier, a hardware generation, a number of vCores. Lots of choices to make that eventually lead to this thing called a service level objective. And the way you do that is you do it through the Azure portal when you're deploying something or making changes. We'll show you an example of that later. Or it could even do T-SQL. We'll show you an example in our demonstration how you're going to use the actual alter database command to change the service level objective for a database for scaling purposes. And then we support CLI. So through PowerShell, through Azure CLI, you can also make these changes. And here are the things that they affect. Look at all these things. By you navigating down your product and all these different choices, you're going to affect the price you pay, the surface area of features that you get, things like resources. What kind of cores do I get? What type of cores do I get? Things like storage sizes and IO performance and temp DB, all sorts of different things that can affect your ability to be successful in the cloud. But look at these things in the bottom right-hand corner over here. The storage type you have, the high availability architecture we deploy for you, the capabilities, the replicas, and again, even the service level agreement, even though a SLO is not that, it affects what options you get for these choices. So you can see now when you look at this bullet list, how this correlates to what we talked about in the first slide. Because you have decided for your app, when you're deploying on your own, what kind of resources do I need, both from a CPU, memory, and IO perspective and storage perspective? And then what kind of configuration options do I get, and what availability requirements do I get? So we're going to go into more detail now and compare Azure SQL Managed Instance and Azure Database, what these decisions and choices look like. So one thing I want to point out in the next couple of slides, this point of subject to change. Subject to change, I point that out on there because we're always evolving the cloud. In fact, some of the things I'm going to show you, we're currently working on to expand our capabilities. So when you see something in a slide, just know that even on sometimes on a monthly basis, we look to preview things that can affect things I'm talking about today. So let's compare again this managed instance with Azure SQL Database. So for managed instance, it is an instance of SQL in platform as a service. It's a managed service, but it is the complete SQL surface area. So like SQL agent jobs, for example, are going to come with not only you get the ability to have databases, but you can have agent jobs or transaction replication, things that are instance level like capabilities. Now, we talked about the concept earlier of a service tier, and I'll drill in a second to that. You're going to have choices of something called a general purpose or business critical service tier, which are going to affect the SLO choices you get for a managed instance. Now look at some of these capacities. The maximum storage today for a managed instance is 8 terabyte. You only have a Gen 5 hardware choice, which means the maximum cores you get are 80 vCores or 488 gigabytes of memory, which is kind of like a per core type memory choice. So now you could look at this list right now and decide maybe this might not meet my needs. I might need a different choice, or maybe this fits within the capacity and resources I need for managed instance. And then from a high availability perspective, we'll talk about general purpose and business critical in a second for managed instance. But note also, to go further with availability, you do have the concept of something called an auto failover group. In managed instance, and today in preview, we have a concept called an instance pool, which allows you for faster deployments or to have more condensed versions of managed instances in a pool fashion per your needs. That's going to give you some things like lower amounts of minimum vCore choices you might want for managed instance. So Azure SQL Database has some bigger choices, but also some more limitations. So for example, database scope features exist with the Azure SQL Database because it is a database, not an instance. So if your requirement was, say, SQL agent, you don't have that with Azure SQL Database. You would need to use a managed instance. But if you're just looking for a database and those core SQL requirements, this could meet your needs. And then look at these other expansion of choices. For example, you have new service tiers for general purpose, business critical, and hyperscale, which is going to give you the ability to have up to 100 terabytes of space, which you would not have today in a managed instance. You also get multiple hardware choices. So for example, you can go up to 128 vCores and 4 terabytes of memory in a database where you couldn't do that in a managed instance today. You got other options. Things like serverless compute to do pausing or pay-as-you-go type compute or auto scaling. And from a high availability perspective, you have, in addition to auto failover groups, things like geo-replication or things like zone redundancy, which can give you a higher SLA than, say, you might get today with a managed instance. In addition, if you want to manage a bunch of databases at scale, we have the concept called an elastic pool. So you're making a product decision first to get to that SLO. You're going to decide, is a managed instance right for me, or is an Azure database right for me? Now, once you go into managed instance, you have these service tier choices, which are going to determine the SLO you're going to get. So we have something called a general purpose and a business critical. And from a pricing perspective, we only have the vCore model today, not DTU for managed instance. So if you look at general purpose, this is for most business workloads, and we use remote storage as a way to give you this general purpose capability. Well, what does that mean? Well, you get more space actually than you get for business critical, but you're going to get something called basic IO performance. It's good performance, but it's not going to be as good as, say, a business critical service tier. It's going to cost lower, but you're only going to get one primary replica. Think of like a failover cluster instance for you using remote storage in a general purpose environment. For business critical, the differentiating factors are local storage with SSD, so fastest, best IO performance for a managed instance. It's going to cost more, but what do you get for that? You get faster failover because we're using replicas. You get features like in-memory OLTP, and notice here you're going to get multiple replicas, including for free a read-only replica. So you can see now, when I get down to this SLO choice of cores I'm going to make, going to general purpose of business critical can have a decision for you on what capabilities you need for resources and for availability. Okay, let's talk about Azure SQL Database now. Let's say you went to that product and that was the choice you made. First of all, before I do that, notice this arrow between these is very important to call out because you may not get this right when you first make this decision. You can in managed instance switch back and forth between a business critical tier and a general purpose tier. So let's talk about Azure SQL Database. You now have 3 different options. Now, in this particular case, we're going to focus on what's called the vCore model. You do have a concept called a DTU pricing model, in which you have something called a basic, standard, and premium set of tiers. I'm not going to focus on that today, but that is an option for you. It can be a simpler choice to make, but you don't get as much granularity, which is why I like to focus more on the vCore model. So let's talk about these service tiers here. Notice this time I still get a general purpose, I still get a business critical, similar to why I got a managed instance, but I get a new one, something called hyperscale, which we'll talk about in a second. Now for general purpose, very much like you had with managed instance, you're going to get remote storage, basic IO performance, but notice here that the fastest core options, remember there are multiple hardware choices you get with Azure Database. The fastest CPUs available, those come from a general purpose service tier. And in addition, if you want this concept called a serverless compute, pausing capabilities, auto scaling, pay as you go type compute, that is only available in the general purpose tier. And like a managed instance, though, you get a primary replica, and it's going to kind of feel more like a failover type cluster instance. Now, what about this business critical? It's very similar to managed instance, local storage, best IO performance you're going to get of any of these choices. Here's where you're going to get more core and more memory than any of the choices you have, all 3 of them. It's going to cost more, but you get your highest SLAs here. Your highest availability is going to come from this choice. Faster failover times because we're using replicas like in a managed instance business critical, and things like in-memory LTP are only going to be available in this slot in this service tier. What about this hyperscale thing? This is really important. It's going to use a combination of local and remote storage to give you fast IO performance, but the best scaling, and that's one of the big promises of hyperscale, and unlimited storage. We talked about that 100 terabyte type option. That's only going to be available on this right side with, say, a hyperscale. Fast failure is going to occur. We still use a replica design. It's not exactly like business critical, but notice in the diagram here, most of your read replica options are going to come here. You have the option of using no replicas or up to 4 read replicas, and read scaling becomes a great opportunity with hyperscale. Now, if you go down this product choice and you look at these tiers, you may ask yourself, how do I move around if I don't get it right? Well, number one, you can go between general purpose and business critical today, but hyperscale is a one-way street today, at least. So if you go to that hyperscale option, you cannot move back to general purpose and business critical. I thought it'd be important before we're done to show you an example of something where you might not get it right from a scaling perspective from a number of vCore choices. So let's flip over and show you. I'll pop over here to, first of all, the Azure portal. And I'm showing you here that I've deployed an Azure SQL database that's a general purpose service tier, Gen 5 hardware to vCore. Now I'm going to run a workload for you and show you how you can easily scale this if perhaps you didn't get the number of CPUs correctly. So let me kick off the workload first and then show you a few things. So over here using Management Studio, I'm first going to show you how do you look at this SLO thing? Like, how do I figure it out? Well, we have DMVs and T-SQL commands that you can run to see what is my current SLO. Well, look at this. This is a product of Azure SQL Database. That's the SLO. General purpose Gen 5 to vCore. So in essence, that's my compute choice I told you in the beginning to give you the performance you want. But because I made that choice, I also have those other types of resource limits I talked about from capacity, storage, and availability choices. So I'm going to run this, and if I go look over here at some DMVs to see performance, I can tell already that I have kind of a CPU limited workload. These type of indicators show me that I probably don't have enough CPU resources to run my workload per what my needs are. So what I can maybe do here is I can go inside here and I can see, in fact, let's just go over real quick and see if this is finished. You can see that the workload finished in 45 seconds. Well, you may not know if that's good enough, but it did seem like I had a high CPU utilization that I ran that. And I can tell that from looking at another DMV. This is all built in with T-SQL to the service called resource stats. This kind of showed me that if you can see here for this period of time, my CPU was pretty high during that window. I almost used all my CPU capacity. So it'd be kind of cool if I could scale it. Well, I told you before that one way to change your SLO is through T-SQL. So let's do that right now. I'm going to change, remember we call it also a service objective, to 8 cores with the same choices I had from a general purpose Gen 5 hardware. So let's go run this. And it's kind of an asynchronous operation. So if I go over here and I go back look in the portal, I can see that behind the scenes what's happening is this is updating what's called the pricing tier. It's another name for this SLO or service objective we're trying to do. Notice here in the portal, I can tell from Azure Monitor built-in metrics that I was using 100% of all my capacity. So what I'd like to do is I'd like to simply just go to 8 cores with no database migration. Wouldn't that be nice? So by running that T-SQL command behind the scenes, we are going through and we are upgrading you to 8 cores, but there's no other change required on your part. I can go back here now to my management studio. Let's go back over here and look again right here. And I can go back and see, am I at 8 cores now? Well, I can run this command to see, indeed, I am. It's the same Azure SQL database. It's the same general purpose. It's still Gen 5 hardware, but now it's 8 cores. So is that any faster? Well, I don't know. Let's go back and run the workload again and kick it off. And if I run this now, what you'll find out, this took like 45 seconds before, but because I was limited on CPU resources for my queries, this is going to take no more than like 15 seconds to run. I'm still going to use CPU resources during this time period, but you can see how simple my choice of just using the portal or using T-SQL, now I ran that workload at least 3 times faster by making an easy and dynamic scaling choice. Here's the other good news, that if you go to something like serverless, this would have auto-scaled in the first place by itself. Okay, let's go back over to the deck and just kind of finish off here a little bit. And I know we're right at the top of time that we have here. So I want to give you some more resources because you've got a flavor of what this is, but you want to try it yourself. Go check out the Azure SQL Fundamentals, a Microsoft learning path where you get a free sandbox. You can run the exact same demo I just did so you can learn more, all sorts of other rich information, what's going on about what a SLO is in these service tiers. Another thing I want to point out is Azure SQL for Beginners, a 61+ video series of bite-sized chunks where Anna Hoff and myself will go in a lot more depth about a SLO and a service tier. And then why not a shameless plug for books? If you want to go see more internals about how this works with a service level objective, read Azure SQL Revealed. Or if you're a developer looking to get started with Azure Database, go take a look at Practical Azure SQL Database for Developers, a great resource for anybody getting started with database as a developer. That was a ton of stuff in 20 minutes, but I hope you understand the concept of making the right choices in Azure SQL and how a service level objective can make that better for you. Here's good news for you. We have tools we're working on now to give you guidance, especially during migration scenarios, to help make that choice easier. So that is the end of our presentation today. I really appreciate your time. I'll take a second here, and it looks like I got one question for to be answered that I'll try to provide. And if there are other questions, of course, I'll be happy to stick around or answer them in the Teams channel. So what is max DOP and how does it depend on vCore? And let's see, let me go back. That's under the published one here. Here we go. So max DOP is called max degree of parallelism. It's a SQL Server configuration parameter. And I'm glad you asked that because the SLO you pick can dictate the maximum possible of max DOP. You can kind of configure that if you'd like underneath that parameter, say like in managed instance with an SP configure option, but the maximum degree of parallelism is going to depend on how many cores you deploy. We document exactly what that looks like, or guess what? There's a DMV you can use, DM user DB governance, where you go resource governance, where you go look in there and we'll display for you the max DOP you get for parallel queries based on the SLO choice you make. It says here, what kind of managed instance would you recommend for a classic data warehouse? So know that one of the greatest features in SQL Server for warehousing scenarios is column store indexes. Here's the good news. That just comes with Azure SQL Database and managed instance. So just about every option you get, with a few exceptions, you get column store indexes. So classic warehouse scenarios are perfect for those designs. And of course, if you're thinking about a really expanded scalable warehouse, Azure Synapse Analytics is also a great choice as well. Let's see, are there any other questions? There's nothing else that really kind of stands out here today. I really appreciate your time. And I hope you enjoy the rest of the ADF event. And I will go, of course, monitor our team site, US sessions for this session to see if you've got any additional questions so you can understand what is a service level objective, why does that matter, why is it important for you for making the right decisions to get the best performance, the best features, and the best availability for your choices in the cloud. Thanks for your time today.